So welcome to the history of software testing. So the talk is called Testing History from the Caveman. This has nothing to do with caves, but 1 year ago I looked like a caveman, I had a long beard, but that has gone so far. Cool, so who am I? My name is Ilari Henrik Aegerter. I'm from Switzerland. I'm the managing director of a company called House of Test. I'm also the VP of marketing, so just be careful. Marketing people, they bullshit you, so just be careful what I'm saying. Of the Association for Software Testing, which is a non-profit organization in the area of software testing. Then I'm also an instructor at the Technical University in Rapperswil, which is in Switzerland. We have just been developing a postgraduate study for half a year for software testing, so I'm going to talk about that a little bit later as well. In my free time, I'm a family man and I brew beer because beer is something pretty nice. So I see him winking over there. No, not for me. Okay, cool. Good. So I hope you got up very nicely and you're awake. So let's play a little game. Just be very careful to not lose. Are you ready? Okay, so from now on you will pay attention. I can see that. So this is the history about software testing and about software development. There will be a lot of elements on the development side and on the idea sphere as well. These kind of things are usually helped by a lot of people, so I would like to specifically thank Robert Severin, Michael Bolton, Joris Merz, and my team at House of Test, who had a very critical eye on the presentation and proposed some additions. Specifically, Joris Merz, he has a site on the history of software testing, which is a table with all the elements of how we came to where we are now. Good. Caveman. So let's start very early. So this is 38,000 before our time, so very early. As you can imagine, no Apple notebooks yet at that time, but as you can see, there are some hands on the wall. I believe that to be human is to test. That is something that is very inherent in our character and who we are. So as you can see here, these people, they just put their hands on the wall of the cave in South Sulawesi. So this is the cave of Petakere. And they just wanted to try out what happens if can we multiply our hands? So it's just testing and finding things out. Now you also know where the term manual testing comes from. So it's from back this time where they just put their hands on the thing. I will talk a little bit about manual and automated testing as well, and why that is a concept that's a bit less than ideal. Cool, let's jump ahead, 87. For our time, so that's the Aegerter mechanism. So it was used to predict astronomical positions with the Greek. So this is supposed to be the first kind of computer that did some work which was not just on a piece of paper or something. And it's kind of the first analog computer that is known. A big jump ahead, so 1804. So now you will see that there is some sort of color coding. So there is yellow, which is everything that's supposed to be with testing. Then red is anything that's supposed to be with computer engineering. Blue is from the ideas world. White is companies. Gray will be tools. Pink is conferences. And then there will be a green one, which are video games. So we will see that as well. The Jacquard loom used for the first time punch cards. So as you can see here, these are punch cards that were used to weave these very nice patterns. And this is a machine that actually, for the first time, did some regression testing. What they did, anytime they modified the machine, they let run their old punch cards and wanted to see whether or not it still produces the same result. So as you can see, regression testing goes that far back. It's more than 200 years ago where the first time regression testing was performed, although I doubt that they called it that way. These punch cards, they were a big inspiration also for Charles Babbage and IBM later on when they produced the first computers. So this is the next one, the difference engine by Charles Babbage. It is a mechanical calculator to tabulate polynomial functions. So this is the first time that there was a kind of a mechanical computer doing stuff. Now, Ada Lovelace, had an inspiration with this machine, so she thought, okay, it shouldn't do only these fixed calculations, but maybe we can run algorithms on that machine. And so, as you can see here, this is the first time where she set up an algorithm that could potentially be used with the machine of Babbage's. 1843, a very good insight into how nature works. So there was John Stuart Mill who wrote A System of Logic, and he introduced the term inductive reasoning. And that is based on the insight that in general nature is uniform, so which means that nature behaves in a predictable way most of the time. And inductive reasoning is very important for the way we think about systems in general. 1878. You might have seen this first bug report, this little card that has actually a moth taped on it from 1945, that will come later. Many people think that the term bug was introduced in that time, but that was actually the first bug report. Thomas Alva Edison, he spoke about system flaws that he discovered in his systems. These were telegraph systems, and he called them bug. And he also wrote about it, so now you can't read it here, but he has a long letter where he speaks about bugs, and there is a bug in my apparatus. And that was in 1878, so pretty early. The bug as a concept was already established. We have 1889, IBM. Doesn't play such a big role nowadays, but it was founded then as the International Time Recording. 1890, Herman Hollerith, he first introduced a machine that also used punch cards, and built a machine that could run all these punch cards and do calculations. And his company later on was acquired by IBM. So the first books, as you might notice here on the table, we have a little bit of a library here. And I'm a collector of old books in general, and anything on software engineering and testing in specific. So here we have testing electrical apparatus. So here we have a lot of instructions on how to test something that is electrical, and it also mentions for the first time that there should be a set of standard tests performed on electrical apparatus in 1924. 1925, this book for the first time mentions load tests for machines. So what they did in the electrical machines, they wanted to see how much load they can take. So load testing was something that was mentioned in a book from 1925, and that's here. Also, if you're interested after the speech, if you want to have a look at these books, feel free. I'll be around, and you can have a look at these primary sources. Then 1930, this is the first kind of a sales catalog for load testing devices. So as you can see here, there are these wonderful little things in there where they sold machines to load test their electrical systems. Okay, doesn't have to do anything with pure software testing yet, but it's kind of the first ideas that came along on that. So, Walter Andrew Shewhart, he said something very important that actually got forgotten nowadays. So what he said is that data has no meaning apart from its context. Now, if you remember in your company when your manager asks you to give some metrics, just some numbers, let's say pass rate percentages, and just presents that as a number completely detached from its context, it probably doesn't make a lot of sense. And in 1939 already, he spoke about that data doesn't have any meaning apart from its context. He also spoke about data having both a signal and noise. So whenever you present something, there is a certain element of noise that masks the true meaning of what you're trying to present. And I think this is something, especially when we want to, or we're forced to give a test report, that we should keep in mind that there might be some noise in that report as well, and that you need to put the context into the report as well. Any number should be put into context. As I mentioned before, this is the first bug report. So you see this little card, and actually it has the bug. I think it's the only bug report that contains the bug itself. So that is just a stick there. So this was in September 1945. Grace Hopper found this muff between the relays of the Harvard Mark computer she was working on, and she filed that report for the first time. Also 1945 brought us the von Neumann architecture. This is quite interesting because von Neumann, he was not American, so John, of course, very American name, he migrated to the US from Hungary, and his name was actually Neumann Janos, and where the von came from, I'm not sure, it just makes it sound better. But basically that says it's any stored program computer in which the instructions fetch and the data operation cannot occur at the same time because they share a common bus. So this is what our computers are based on. A company was founded, ISO, the International Standards Organization, which is located in Geneva in Switzerland. It does a lot of good work in terms of standardization in areas where it makes sense. But to me, standardization makes sense in areas that take harm from variation. So let's say electricity plugs. Just imagine electricity plugs here in Russia. Everyone would be very different. You would have to carry along a lot of adapters. That's not very good. And I'm also sure that you're pretty happy that all your batteries you use for your devices, like in here, that they are standardized, they're AAA, AA batteries, that there is a standard for that, because otherwise we would have a mess. Other areas actually take harm from variation. One of that is software testing. So software testing should not be standardized because it's variation that brings insight and results in testing. So ISO has been working in various areas. Unfortunately, there is a lot happening in the testing sphere as well, and I strongly disagree with that. 1949, Alan Turing wrote a conference paper on checking large routines, and what he wrote in that is the programmer should make a number of definitive assertions which can be checked individually. Now, so far, pretty good, and from which the correctness of the whole program easily follows. I like that easily follows. So you just check a little bit and then everything will be fine and you won't have any problems. Still, 1949, I think the statement that you should have a definitive assertions about your program is something good to think about. What I also always find a bit difficult is to value things that happened very far in the past with our today's standards. So we should always put the historical context in front and think what they already had and that they actually started on a green field and didn't have anything they could base their things on. So this is the first time when someone thought about the term quality. It's quite amazing if you go to your company and ask people, so what is quality? Usually people can't give you a snap answer to that. So what is quality? And people usually don't have a quick answer what quality actually is. Sometimes it's just this view that this is this kind of little sugar cube you just kind of add to your product and then the quality is there. But actually what does quality mean? And so his term was that quality is fitness for use. And this is a very neat, short description of quality. So if it is suitable for its usage, it has good quality. That's pretty good. He did a lot of thinking on who the users will be. So in terms of quality, he thought, okay, who are actually the users that will be using that? If you have software that is used by, say, engineers and mathematicians, it can be more complex than, say, if it's being used by say, children. So if it's a children's game, at least it needs to be less complex. So the user plays a very good, a very important role on if something has quality or not, and how it will be used, and also how fast does it need to be delivered. I think there is quality in fast delivery. It might not be the best of all qualities, but still it's quite an important element to that as well. Cool, so now we go into the games world. This is just because I like games. It has nothing to do with software testing, but as we go we will encounter a couple of games. I find it fascinating that the development of computers and software engineering was in parallel to game development as well. And this was the first tic-tac-toe game called OXO. You can see it's pretty simple. Armand Wallin-Feigenbaum, total quality control. I think this comes very much from the production line world where people produce things. but it has some important elements for testing as well, because it stresses the involvement of other departments like accounting, design, sales, customer support, marketing, purchasing, which also need to be taken into consideration whenever you build something. But total quality control, I don't think this is very applicable to software testing in general. 1957 wrote the first chapter of on software testing. So this is McCracken. It's a book from 1957, and he has a full chapter where he speaks about program checkout. So once a program has been written, it must be verified or checked out to determine if it actually does the job it is designed for. The steps of analysis and programming can lead to many logical errors, i.e. errors in conception or in flow through the problem. So there's a lot of thinking on that. Quite interestingly, McCracken doesn't speak about test cases, he speaks about check cases. So his term of that is check cases. I find that quite interesting. We will encounter the checking, testing thing a little bit later on. So in the second edition of that book, Charles Baker wrote a foreword. Until then, 1957, there wasn't really a conceptual view on between debugging and testing. So this was all the kind of the same thing, just trying to make the thing work. So all programming, debugging, that was kind of one sort of activity, and testing wasn't regarded as something separate that is done, that has conceptually different requirements than debugging. So he introduced the distinction between program testing and debugging. 1958, this is where Sturgeon's law comes into place. That says 90% of everything is crap, which is apparently true. So my addition to that is, but in the remaining 10% there's still too much good shit. If you walk around the world, there's so much good things to occupy yourself, but it's still too much, and that's perfectly okay like that. So focus on the 10% of the good things and just leave away the 90% crap. Also in my daily life as a consultant, most companies are really struggling in doing testing. So again, there what I see is 90% is crap, but this is not because people are bad, it is just because of Sturgeon's law. So most of the things are not really good. 1958, so this is a name you should absolutely remember. Jerry Weinberg is a very wise man, and he is one of the grandfathers of software testing. And he was involved in the Mercury program, which was the first space program of the United States, and it was running from 1958 to 1963. Jerry was a technical manager in that program, and what he established in that program was the first software testing team. So 1958, the first test team came into being. Also 1958, tennis for two. I don't know if some of you still know these little video games that you connected to your black and white TV, and you had these little black boxes where it just turned around. So Pong, you remember, David? So these were the first kind of games which were really simple, tennis for two. So 1961, this was the first book that was also written by Jerry Weinberg and Harry Leeds. And it had a chapter that spoke about program testing. So this is not program checkout, so it really had a chapter on that. So in order to be sure that the program is right, a simple and systematic approach is undoubtedly best. However, no approach can assure correctness without adequate testing for verification. So it already speaks about that there is no way that you can make things right at the very beginning. When you program, you need to test it. And he speaks also about automation, and in some of his later papers he speaks also about the limitations of test automation. This was in the 60s, where Jerry Weinberg stated that if you implement automation, just be careful, because this is another software engineering project and it needs maintenance, as does the production code. So already in the 60s he had a warning finger about being careful in over-reliance on automation. Space War, 1962, with a very beautiful round screen here. Then 1967. So as you can see here, there was a white paper by IBM. It was the evaluation of the functional test of control programs. And what it speaks, S stands for specification, P stands for the program. And as you can see, there are a couple of things that are overlapping. So if you have something in the specification, that doesn't mean that everything that's in the specification will actually land in the program. So this is the program circle, this is the specification circle. Ideally, anything that you specify will be mapped to what is in the program. But in the program, you find a lot of items that are not in the specification, yet still present in the program. Now, who finds this is a problem? Can I see some hands? Is this a problem? Well, no specification ever states that the program shall not create a nuclear meltdown. So that's not stated, but it's still something that needs to be present. There is a lot implemented in programs that's not specified, but is implemented by programmers because it's good practice and that's how it should be done. So other things that are present in the program but not specified, they can be a bug. And out here, this is the world which is not specified and not in the program. That can also be a problem because some things just got forgotten. So let's say you have a functionality that you really need to implement, the users actually need it, no one thought of it and it's not in the program. So this is certainly also an area that testers can focus on. But basically the white paper spoke that software engineering should have a more scientific approach in general. I think software engineering is fascinating because humanity hasn't been doing it for a long time. We have a great deal of experience in areas like building houses. So like this house won't collapse because we have been doing that for thousands of years. We have a lot of experience in how to build houses, how to build bridges, and other areas where we have hundreds or thousands of years of experience, whereas software engineering and software testing is very new in the world and we don't have a lot of experience with it. So a lot of these thinking are very novel and probably in 200 years we will laugh about it and think, what did we think back then? Cool, this slide here has nothing to do with my presentation, I just like the picture. This is Apollo 9. Well, maybe that's a caveman coming out from in space. So this is Apollo 9. Still leads to the next slide, software engineering as a term. So developing software, it was not really clear what it is. At the very beginning, people thought that building software is more a mathematical problem, something that needs to be solved, that needs to be approached scientifically, and that is not an engineering approach. There is a good book by Cohn that speaks about engineering doing the best outcome with limited resources and a limited level of knowledge. And that's what engineering is. So the term software engineering was introduced around 1967. It's not really clear who introduced it or who invented software engineering as a term. I will just ascribe it to Margaret Hamilton, who was very instrumental in the success of the Apollo 11 mission landing on the moon. So she wrote the error handling routine for the lunar lander. And so she did a very great job, and she actively spoke about software engineering as a discipline, that software needs to be approached through engineering practices. 1968, there was a NATO report that mentions software quality assurance, and what it states is that software quality assurance should definitely be done by separate groups, and that the product that you test, you need to ensure that everything goes right, and it definitely needs to be a separate group. I think this is also something that we're struggling with. Should testers be on the side, or should they be somewhere else? Or should they be included in the development teams? My current opinion is it's probably better if testers are part of the development team and are fully integrated into, say, an agile group of people and not separate. So I think the silo or testers just on the side, or even worse, being outsourced in a different geographical location, I don't think that makes a lot of sense. 1968, Edsger Dijkstra, a very important person in general, so he had a call for structured programming. What he said is the tools we use have a profound and devious influence on our thinking habits and therefore on our thinking abilities. Meaning that if you use a specific tool, this will also limit the way you think. If a specific tool doesn't have the capabilities you wish for, you kind of try to squeeze it on the side and don't use it. Conway's Law. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So this is very important, the way you organize your company. That will also lead to how you do things. Or the way I would put it, so if you have an idiot in charge of testing, your testing will look idiotic. This is just the way things work. Conway's Law, 1968. 68, Intel was founded. Most of our chips are based on Intel. Then 68, there was the first conference in Garmisch-Partenkirchen on software engineering, and it spoke about the difficulty to write understandable, verifiable computer code. So I think this is a prerequisite you need to have to be able to test well. If you have a big pile of garbage, it's very difficult to test that. And this was this insight that it is very difficult to write understandable code. Because it needs to bridge the gap between code being understandable by the machines, but also being interpretable by humans. I think very important part. Good. So I think this is my most important slide because that gets forgotten very often. Again, Dijkstra 1969, testing shows the presence, not the absence of bugs. So really important. If you test, through testing you can't prove correctness of your program. You can just show that there are bugs, but you will never be able to demonstrate that there are no bugs in that specific area. This is simply not possible. Some people, especially from the Google domain area, thought that this is possible, and we will see later on that there was a very famous conference talk by Alberto Savoia that speaks about that, and that has this deep confusion about what testing actually is. 1970, waterfall. So our all-beloved waterfall model was published. Again, I think this is very much based on the production line, or kind of the industrial production of things, where you do things sequentially, one after the other. So I think that was just a model that was taken from a different domain and has been around for a long time. And even some projects that's called as Agile actually do waterfall. 1971. I think this was the first approach where there was an attempt to find out whether or not testing is really good at itself by mutating the program on the test and seeing whether or not the automated checks that were implemented will catch the errors by changing your subject. So mutation testing was defined then. 1972. This I played a lot with my brother, exactly on a black and white TV, a very fun game, Pong. Then 1973, program test methods. That's this one here. So this is a collection of articles written by many people. It's quite fascinating because it's got this, you can see this typewriter font, which looks funny, and has a lot of good stuff on testing as well, 1973. One thing that it states is that ambiguity and misunderstanding are the cause of almost as many errors as logical coding, meaning that you can't just have a look at the code, but you need to do sense making and find out, okay, what was the purpose of that product? In 1973 already had that insight. 73 also brought the first Hello World. This was in a tutorial by Brian Carrigan, Hello World, and so this is his original first handwritten version of that. He wanted to print out the Hello World. Data flow diagram, Larry Constantine first introduced that. Then in this time there was a lot of inspection part happening, so the walkthrough method of specification by Waldstein. So this is not Mr. Waldstein, this is just a picture of a duck. I couldn't find one of Mr. Waldstein, so I just added a picture of a duck. Cool. Now this comes a bit closer to here in Moscow. I don't know if you know Morskoy Boy, the little game. And so if you look very closely, this pin here is actually a Morskoy Boy game. Because last time I was in Moscow, I went to the Soviet area arcade museum, which is absolutely fantastic. So anyone who hasn't been there, please do go there. You get coins and you can play all these arcade machines from Soviet area. It's absolutely fantastic. I love it. 1975. Now, this is the first time that you will see this little icon here. This is the oh no icon. So I have very strong opinions on a variety of misguided developments in testing. And so this is towards the theory of test data selection. And it says, examines the theoretical and practical model testing software. And the authors prove a fundamental theorem showing that properly structured tests are capable of demonstrating the absence of errors in a program. Haven't had any exposure to Dijkstra, so they should have looked just 6 years back and had a look that this is absolutely not possible. This is fantastic. Tom Gilb, if you ever had a chance to meet Tom Gilb, a fascinating person, and he came up with the laws of unreliability. And what he says is computers are unreliable, but humans are even more unreliable. Oops. And there's a corollary. At every source of error which is blamed on the computer, you will find at least 2 human errors, including the error of blaming it on the computer. So he speaks a lot about the unreliability and also the difficulty to come up with specifications that are not ambiguous. So human language by its very nature is an ambiguous entity. So that is a property of human languages. Human languages are ambiguous and they need to be in order for us to smoothen out our communication. If it wasn't, it would be something very different. So human languages are not very suitable to do some very correct things. This you probably know, Mythical Man Month, meaning that the urge to add new people to a project when it is late usually doesn't work because it will make it even later. So just adding people will completely disregard the need for these people to be ramped up, and so if you add a person late in a project, it will make the project later because all the other people are absorbed with the introduction and helping that person to ramp up. Important book, Introduction to General Systems Thinking, again by Jerry Weinberg. So basically, Jerry Weinberg, it's very easy. If you want to read books by him, just get all of them. It's very an easy selection. 75, Microsoft founded. That was their logo. It does really look like a 70s logo. So, 1976, Glenn Fort Myers, which will also play a role a little bit later, he spoke about the goals of the tester. So his goal was the tester is should make the program fail. Then 1976 we found the code inspections for the first time. Then 76 what humanity always tried is to try to find how can we tackle software, and maybe some metrics and measures would make sense to find out how we can handle it, and so introduce the cyclomatic complexity. And so that's a quantitative measure that counts the number of independent paths through a program and gives that as a number. And based on that number, you can compare programs as, okay, this being more complex than another one. So I love my Mac. It does not have that logo. So Apple was founded in 1976. This is Newton. This is the Newton's Apple, but still pretty nice logo. 1977. Brought the Atari 2600, where you had the little games that you could just put in as a cartridge on top. I used to play that a lot when I was very young. So, 1978. When we test and we discover something, we need to compare what we discover with some sort of reference. So, how do we know that we find the bug? So, if we observe a system behavior, how can we say, okay, this is probably a bug? We need to have some comparison mechanism. And so, of course, the obvious one are requirements and specification that were around, so you can just have a look in the specification. That states something else, and I observe something that's different to that, so it needs to be a bug. But there is a more general mechanism, and William Howden introduced the term oracle. So oracle is any mechanism or reference you can use in order to detect whether or not what you observe is a problem. So this can be your own judgment, this can be previous knowledge. So very often, if you're in a project that has a lot of releases, you remember 3 years back that what you observe here was then a problem, but you can't find that anywhere in a requirements document. Yet still you can say this is a bug. And so what you're using is an oracle based on yourself. Or the same thing can be the boss of the company, CEO, comes in, I want to have this button green. And if the CEO says so, then the CEO becomes an oracle, and you should better report that as a bug. So what he says, the use of testing requires the existence of an external mechanism which can be used to check test output for correctness. This mechanism is referred to as the test oracle. 1979, so this is the first time someone wrote a book specifically on software testing, so it's called The Art of Software Testing by Glenn Fort Myers. And as said, so if you want to have a look at these books after my session, feel free to do that. What he said, so testing is the process of executing a program with the intent of finding errors. That's Glenn Fort Myers' statement on what software testing is. It also contains a little exercise at the very beginning where he wants to demonstrate that if you have a very simple program, testing can be quite complex. So what he states there is a little program that draws a triangle, and then he asks, okay, can you please tell me how you would test this application? And then on the next page, he asks you a lot of questions. Have you thought about this and that and this and that? So what could that be a problem? This was also made into a little program by James Bach that he often uses in his exercises. So that it's a triangle program where you need to test and find out what bugs you will find. Conceptually, create, retrieve, update, delete. So this was a kind of a sense-making or sorting system. What computers actually do, that they create, they read, they update, and they delete stuff. And based on that, you can also do your test design. Okay, so you can see there is another one of these Oh No logos. IEEE 829 was published. And as you can see here, you don't need to read that, doesn't matter. It has a lot of boxes and arrows, and it looks like a very ordered system of producing tests and documents. And actually doesn't talk that much about testing. It talks more about the secondary work product documents. And this is actually the direction that one part of testing went, that suddenly the artifacts become more important than the performance of testing. So I think testing is something that you perform, it's an activity, and the goal of that is to help make something better. And it's not, the goal there is not to produce a lot of paperwork and a lot of reports and a lot of plans and anything. So IEEE 829 was this first attempt by people that thought, okay, we need to get control over that through documents. It was certainly also a strong influence on the ISTQB. But IEEE now is, the 829 is now substituted by the ISO 29119, which will also die in the future, hopefully. Good. Verification validation standard was published. Did just some reflection on what these terms are. So the first conference in 1983, PNSQC, which is the Pacific Northwest Software Quality Conference, it has been around since 1983. So I think this is the longest running conference on the planet that has been there forever. It has quite high standards, so you need to submit a white paper, and then based on your white paper you do your presentation, and it's been yearly in Portland in Oregon. Cool. So, James Martin wrote a manifesto that the root cause of problems are poorly written requirements, 1984, as an idea. The Software Engineering Institute was founded in 1984 as well, and Tetris came along in 1984 as well. I don't know if you have that as well, that if you play Tetris for a while, it kind of keeps on playing in your head, and you can't stop the film. This is just a horrible game. Autotester, 1985, a tool. Then also in 1986, the V model was published. I allowed myself to put one of these oh no stickers here, because I also find that this is the root of many problems. There is almost unlimited number of companies that I have experienced where they take the V model as a religious document and really try to find a way to adhere to the way of how the V model sees the world. And I don't think this is really helpful for testing. Let's recapitulate a bit. So back in the 90s, people thought, okay, so can we make phases of software testing? So what can we group them into the predominant thought that was present in that time? And so the classification was until 1956, it was a debugging-oriented phase. Testing was not seen as a specific activity that should be done, but basically you program something, it will show errors, and then you do debugging. And testing was not there as a concept. And between 1957 and 78 was a demonstration-oriented period where you wanted to show the correctness of your program. You wanted to show that the software works. Then 79, I think this was with Fort Myers, that the goal of tests is to find bugs. Errors is the destruction-oriented period where you wanted to really examine the program and see, that's wrong and here it's wrong. 83 to 87, evaluation, so you evaluate and you state the way the software behaves. And then we have this prevention-oriented period. I'm not so sure if that is still there. I think the activity of trying to prevent errors is a good one, and it definitely belongs in the domain of testing. But I think if you over-rely on prevention, then you won't find all the bugs. So what area are we now? I think we are currently in the confusion period, so there is a lot of areas that we don't really know what to do, and I think that's okay. It's just something that will resolve in the future. 1988, Ken Caveman wrote the book Testing Computer Software. This is the first time where he spoke about exploratory testing. Now, if you think about it, actually all testing is exploratory. So I don't think that exploratory testing is a specific activity. Whenever, let's say you're in a highly formalized environment where you have to write test cases that have step-by-step procedures, you somehow have to come up with these steps. And the way you come up with these steps is through exploration. So exploration or making experiments, trying to find out what makes sense, is always an exploratory activity. So I think this is something that James Bach also mentioned very recently, that all testing is actually exploratory. There isn't testing that is not of that flavor. Yes, the capability maturity model, again, oh no area. I think this was the attempt to have this neat little sorting mechanism where you can just put people into nice little drawers and tell them how good they do the work. So the measurement of that was more the degree of formality that companies used. Just thinking that if you're doing things in a formal way, then your quality gets better. That is absolutely, there is no basis for such a thing, that you need to work in a formal way where everything is defined beforehand, or where you come up with a big plan and then you just follow the plan. That just doesn't work for software. So CMM and CMMI, I think, are flawed models that don't have any value. There's the first defect tracking tool, DDTS, was made for the Unix market in 1988. Then 1989, Load Runner by Mercury. Just have a look how beautiful that looks, very old-fashioned. 1990, Boris Weiser wrote a book, which is called Software Testing Techniques. It's quite a thick one here. So the first edition was 1982, and this is kind of the second edition. And what he brought in the second edition, he tried to classify the way bugs are. So he had a taxonomy on different bugs. So bugs that are based on requirements, feature, or functionality. There are some structural bugs in the code. There is data bugs, there is coding bugs, and then there is just some general misunderstanding bugs. Boris Weiser. 1991, there was the first news group on software testing. I'm not sure if it's still around. 1992, the Rational Unified Process, developed by Rational Software Corporation, which was then later on bought by IBM. It's quite interesting that IBM has been this sort of this sucking machine that just kind of bought companies here and there, and they also bought that. I think Rational Unified, the RUP, had some merits. It was a little bit too heavy for my taste, and I think there were just too many documents. It was also a system that was very heavily based on documents. Cool, 1992, the concept of technical debt. meaning that if you just keep on going with ever doing any refactoring, you will just add technical debt to your system, and you will have to pay that sooner or later. 1992 brought the first STAR conference. I don't know if you have heard of STAR conferences. These are huge conferences in the US. They usually have something between 800 and 1,500 people. These are massive, massive software testing conferences with a large program. They run for a full week for 5 days. 1993, just imagine, it's already that long ago. 1993 brought Scrum. It's fascinating how Agile and Scrum got hold more or less recently in a large scale, but Scrum was invented in 1993. So this one comes from the Netherlands. So I have a very interesting relationship to the Netherlands because some of my heroes come from the Netherlands, and some of my best testing friends come from the Netherlands. So Dijkstra was from the Netherlands, but then there is also some misguided things like TMAP. I think this is just a system that maximizes the billable hours for consultants in a company because it's so large to implement. So I don't think this is a very good idea. This is my favorite one, TMM. So it's not the capability maturity model, it's the test maturity model. So I just had this very small icon here because it doesn't matter. So this I would classify this as a second degree bullshit. So you take one really crappy idea and then you transform it to your area. So you don't even come up with, I mean, if you want to produce bullshit, then please produce your own bullshit. Don't take some other person's bullshit and make it your own. This is a way of assessing test organizations on their maturity, and again, it is the level of formality that is evaluated and not the way testers do their work. Okay, let's go to something nicer. Heuristic test strategy model, 1996. James Bach came up with that. I can highly recommend to have a look at it. It is a very nice way of making you thinking better about testing. So you can print it out, it's freely available on the internet. If you Google that, you will find it. It is a very good model in order to reflect on your own testing and make it better. 1996, pairwise testing. You've certainly heard of that. So pairwise means that if you have n amount of parameters, and these parameters have a number of different values, if you want to do exhaustive testing, that results in a very large number. So it's if you have 10 parameters with 10 values, then it's 10 to the power of 10 test cases you should have to perform in order to do exhaustive testing. Now, what pairwise testing had a look at was on statistical data on bug occurrence and what kind of combinations will lead to bugs. And what it found out is that bugs either happen if a parameter has one specific value and then the system crashes, or it's a combination of two specific values in two different parameters. But then the probability that if you have 3 parameters with 3 specific values and only that instance will produce a crash gets much, much lower. And pairwise testing is a system where you build orthogonal arrays where you try to combine all the pairs in test setup, and it reduces your testing significantly. 1996, the first extreme programming project. This is cool. This was Google's logo in their phase where they were not yet public, so they used this. Just look, this is horrible. It looks so. It looks like 80s video games font. 1997, there was the first Los Alamos workshop on software testing conference. These are conferences that are quite small, where about 20 people meet, and all the people who are present will also produce an experience report in front of all the others, which then is followed by an indefinite length of discussion. So people in the crowd then will challenge that. And 1997 was the first time this format was used. Mozilla, 1998. There is Apache JMeter in also 1998. 1999 brought the context-driven school of testing. So, of course, also testing, it's kind of the idea world. You can classify that in specific areas and the way people think about testing. And context-driven basically stated that any testing depends on the context you find yourself in. And we will see that later, how someone made this categorical error in assuming something that was from a different context. So you will do your testing very differently if, say, you test a freeware tool that is actually only available for a week and then it gets destroyed, than if you had to test an X-ray machine. So the way you approach testing in these two projects are fundamentally different. And Context-Driven School tried to come up with a thought framework on how to address that. This is beautiful. Robert and Catherine Severin, they wrote the children's book I Am a Bug. And it's a little story about the bug, and you can order that on Amazon, so it's available, and it has this beautiful drawing about the bug, and it's just very neat and cute. Kinefing, this is Dave Snowden's model on how to think about complexity. So what he made a partition between systems that are ordered, meaning that they are deterministic and behave in a foreseeable way, and then he has the complex area where cause and effect are not tightly linked. And this is, you can see that all over the place, and this has been a revelation to me in thinking about software testing, because a lot of software testing thinking, if you think about the IEEE 829, the ISO norms, ISTQB, they all try to handle testing as something that basically happens in an ordered world and is predictable and just needs to use a lot of analysis, and then you can grasp it. Dave Snowden has a thinking model how to act in complex environments. So basically what he states there is that the way to handle that is you conduct a lot of parallel experiments and you will choose the ones that are successful, and then from there you go. Sounds very much like exploratory testing to me. Cool, 2000 brought session-based test management by John Bach. John Bach works for eBay in the US. This is not a software testing technique, but it's a way to please managers and give them data on your testing activities. It gives this little drawer where you can package your exploratory testing so that it becomes reportable and more corporate friendly. That's a very good model. Continuous integration, 2000 as well. Then we're in the year 2001, which brought us a book that every tester should own, I think. Lessons Learned in Software Testing by Ken Kainer, James Bach and Brett Pettigord. It has these neat little chapters that can be read completely independent from each other, little insights in testing. It's a really good book. If you don't have that book, I would very much recommend you get it. So people thought about education testing as well. I think it's a shortcoming that testing can't be studied at a university. It's very difficult to get some good education. And this is one which is pretty good for 3 days. It's the Rapid Software Testing class offered by James Bach and Michael Bolton. And the first one was in Virginia in 2001. 2001 brought the Agile Manifesto as well. I saw the punk horns over there. Do you like it? Yes, well, what it states is really good, and I think what managers and corporations made with it sometimes not so good. But yes, Agile Manifesto, I think what it states is pretty good. There is a lack of testing in the Agile Manifesto, unfortunately. Cool, then we have 2002, ISTQB was founded. So it has its own thing, but this is beautiful because I went to the archive.org page, and I just wanted to see how their first page looked like. And so, yeah, I mean, it speaks for itself. So ISTQB to me is a mechanism to make a lot of money. It is a mechanism to please HR departments who know nothing about software testing. It is a mechanism that puts paper piles and process in front of skill and acquisition in testing. It is a mechanism that allows companies to sell overpriced courses that have a very limited view, and so there is always this argument, it will give us a standardized language about testing. This is complete bullshit. It's my background is in linguistics, so I have studied languages as a concept in general, and languages are something that are negotiated culturally, so you can do that. There are good examples where it doesn't work. If you compare French to English. In French, there is the Académie Française, which tries to steer and control the language. They fail spectacularly at doing it. English has the Oxford English Dictionary, which is an observer of the language and a describer, so it's more an ethnographer of language, and they're much more successful because they just look at what's happening. Language is negotiated socially, it changes over time. If some instance tries to control it, that will fail utterly. So these certifications, they're very useless. I can give you an example. I used to work for eBay, and one of my people left the company and applied at a large telecom company. And so during the interview, they asked him whether or not he has an ICQB certificate. He said no, but I worked on pretty large systems. They stopped the interview and told him to go. So it's gone completely mad. Okay, I'll stop here. Let's go to next, test-driven development, 2002. Then 2003, Brad Pettigrew came up with this kind of school system. So there is the analytical schools, which tries to find mathematical proofs of correctness. Factory school is the one that handles testing as something you can put into a factory, and then you have unskilled workers just processing their test cases. Quality assurance school is, I would call it the policing school that looks for process adherence and just document and everything, and the context-driven school. You could add to that the agile school of testing as well, of course. So you might have seen that in Lisa Crispin's book, Agile Testing, but it's actually by Brian Merrick. It's the testing quadrants, and it is a sorting system to how to think about testing. So, by the way, I think these slides will be available, so you can have a look at them later on. 2003, the Association for Software Testing was founded, and ever since has done a lot in testing. Selenium, 2004. 2006 brought the first CAST conference. This is a pretty nice format because it has a much larger section of interaction with the audience. It has 2/3 of presentation and 1/3 of very long discussion that are organized with cards. I won't go too much into that right now. So, ISO Forms Working Group for ISO 29119. I actually, so I had to go a little bit further with that because that is true horse shit. This is just a crazy document. I bought it. You can't just have a look at it because it is behind the paywall. It will cost you about $700 to buy that, and then you can show it to anyone else. I have a copy. I have had a look at it. It just makes me cry. Again, it's also a priori wrong because it has the view that you just need to control everything and then you will be right. Let's move on. UTest was found, the crowdsourcing company. So if you want to earn a little bit of money, you can actually subscribe with them, and then they pay you for the bugs that you found. Then I couldn't resist to put our own company here. It was founded in 2008, but let's move on. The conceptual difference between checking, which is something that can be evaluated through algorithms and testing or experimentation. So I think this is a thought model that distinguishes between heuristic approaches to testing and one that you can use algorithms to do that. 2009, Agile Testing. I think this has been a book that has inspired a lot of testers and given guidance how they should position themselves in Agile teams. Both of them speak often at conferences, so you'll see them. First, Agile Testing Days. So this is an adaptation to, okay, we have Agile Testing, so let's see what we can do as a conference. I can recommend this, the Testing Circus magazine. You can download it for free. It's a PDF. It has a lot of good articles in it, and it's been around since 2010. Okay, this is beautiful. I really recommend to watch this video on YouTube. So just, if you Google Test is Dead by Alberto Savoia, you will find the video. It was presented at the 2011 GTech conference. It is spectacular. Alberto Savoia he's actually funny. So he comes as a Grim Reaper, you know, he comes on stage, and then there's the end played by, so all spectacular elements that are there. So the doors, the end is playing, and he comes on stage. He's utterly wrong. So he speaks about how testing is dead, and so he's actually, Alberto Savoia is just an asshat. But wait, let's have a look at Graham's hierarchy of disagreement. So I just called him an asshat. So let's classify that. Okay, so this is the lowest argument that you can use in a way. So okay, that wasn't really good. Okay, so what should we do? Let's try to attack the central point of Alberto Savoia. So what he did is he actually did not attack testing, but he took a very flawed example that he has seen in his limited exposure in testing and attacked that. So what he attacked was a straw man. So he built up something that is not testing and attacked that and derived from that testing is dead. So he can't be wronger than that. Still, watch the presentation, it is pretty good. 2012, first Let's Test conference, which was pretty crazy because sometimes it had programs that started at 5 o'clock in the morning and ended at 3 o'clock the next day morning, non-stop. A beautiful conference with very passionate testers. 2013, the International Society for Software Testing was founded. So I was part of the foundation of that group. Our main mission was to poison the well on the ISO 29109. So nowadays, if you Google ISO 29109, the first about 4 pages, you will see critical articles about it and how it doesn't really work. It seems to have come to a halt, and that's good. It belongs on the dump pile of history. Cool. No longer exists. We closed it in 2016. 2018, that's this year, the first time at the Technical University there will be a course, a postgraduate course that lasts half a year that teaches software testing. And I would encourage anyone, if you have contacts to universities, you should talk to them and ask them whether or not they would be willing to have some courses on software testing. Now, as you might have noticed, there are 2 flaws in my presentation. Well, there are many flaws certainly, but 2 of the flaws of my presentation are I have nothing about Russia, so I would be really interested on the history of software testing in your country. I have no idea. You must have something. Also, it is a bit thin on women in testing, so if you know something that should be added to that, please talk to me. I'm around all day, and I would be really interested in kind of what material I should look into, especially in testing in this country. With that said, thank you very much.
My name is Alexei.
Hey, Alexei.
Hi. So it was a good presentation. Thank you. You told a lot about history, but could you please share your thoughts about the future of testing?
I have no clue. I don't know anything that goes beyond 1 year, and if I attempted to say something about that, I would speak about flying cars and artificial intelligence. No, honestly, I think the future develops in a way that can't be foreseen. Anyone claiming that they know anything about the future, they're either crazy or they're just making things up. And some of them will be right, but it's just a statistical fact. So, in general, what I think the direction that we go to is more integrated team. I also think that testing becomes something where the testing aspect is super important, but you still need to have a technical foundation in order to do good testing. But again, I might be completely wrong, so I'm very careful in saying anything about the future of testing. I believe it will be more integrated in development teams, more technical, and the way of critical thinking and trying to find good ways how to test will be appreciated as a specialized role in development teams.
Thank you.
You're welcome.
Друзья, может быть, кто-то сразу еще, или мы приступим к вопросам со слайдом. Да, все. Slide, please.
Okay, so have you been involved in blockchain? So one of my people tested Monero. So what he did was more the wallet. He tested the wallet. I haven't tested anything on the blockchain. Also, never forget, I'm a manager. I can't test. I tried work. It's not for me. That's why I'm a manager. No, but one of my people at House of Test, he did the testing of the front end of the wallet of Monero. But how to test blockchain as such, I don't know. It's something which is really difficult to say. Okay. What type of games do you prefer? So nowadays I prefer more the card games and dice and kind of these sorts of games, and less the computer games. I lack a bit of time to do games. I've been gaming a lot while I was a child, but nowadays I don't. As you can see, the gaming stops somewhere, so I don't have any new that. How do you hire testers? Okay, so the testers that I hire as a tester need to have a software engineering foundation, and then I expose them to critical thinking. So what I want to see is that they are extremely critical thinkers, and that they can come up with very good ideas on something that is unknown, and then on the spot very fast. And what I also want to see is that they have a history of learning, so that they can demonstrate that since they left school, they have been constantly doing Coursera courses, being at conferences, being at workshops, doing that, reading books and all that, so they need to do that. And then what I also do, I let them test things, and I observe them while they test. So this is like when you hire a juggler for a birthday party, you want to see how that juggler juggles balls. So I want to see how a tester tests. So they will get an application, they will test it. And they will explain to me what they're doing. So that's how I hire testers. Why do you think that it is wrong that ideas, for example, Scrum, become famous and widely used? General human inertia and lethargy. I think people exposed to new ideas just take a while. It takes a while until new ideas will take root and are accepted. So I think it just takes a while until, if you're exposed to something new, your first reaction might be that you're confused, and then it just takes a while until you can adapt that. What would you recommend to focus on to prepare for ICQB exam? Well, abort that exercise. Just don't do it. It's useless. You will be misguided with an idea that's 40 years old and also didn't work back then. So this, what you're buying is a I don't know. You're buying a East German Trabant. That's you don't want to do. You don't want to have that. Focus and prepare on ICQ. Well, but if you have to, so I would focus on not losing your sanity. So maybe that. Okay. What do you think about QA in the future? Testing will remain central. All our systems rely on software. So we better get really, really good at testing to test self-driving cars and Internet of Things. And when everything is connected, we need to be able to find a way to make sure that the world doesn't end just because of a stupid bug. What do you think about automation? It's only one way to the future? No, what I try to say is that the distinction between manual testing and automated testing makes sense in the same way as it would make sense to apply that concept on software development. So if I ask you, are you an automated developer or a manual developer? I mean, this is a stupid question. I also think it's a stupid question in testing to make this separation. There's just testing, and sometimes you use tools for that. Sometimes a machine can do the job better, and sometimes human intellect can do it better. And the good testers know when to switch from what part to one part. It's not a binary thing. So automation, there's not automation and manual testing. Sometimes you just use scripts, or you just take automation to accelerate your testing or to create test data, and then you explore again. So I don't think the manual automated distinction makes any sense whatsoever. Okay, what do you think about involving AI in software testing? I'm scared shitless about artificial intelligence, and I think we should absolutely stop doing that. So there is a good article by Wait But Why on artificial intelligence. If you read that, you have to sit down. It's really, really scary. And the reason there is, as soon as the threshold is arrived, artificial intelligence not only becomes more intelligent than humans, but it also becomes much, much faster in acquiring or becoming better at it. And what that actually means. Conceptually, I don't think we have a grasp on what it means to be more intelligent than the most intelligent human. This is something we can't describe. We actually don't know what it is. So artificial intelligence and reaching out to extraterrestrials, I think we should not do that. Okay, what type of testers? We have that. When testing die? Testing dies when we are removed from the surface of the planet. So when humanity is gone, then testing will be gone as well. Could you provide the whole list of books which you demonstrate during the presentation? Yes, I can do that. It's actually in the slides, and I think the slides will be available. So I'll put them in there. So what type of testers should do when you're hiring? So the people I'm hiring, they should just very interested. They should demonstrate that they can do testing. So if someone applies with House of Test, they need to demonstrate the testing. I don't care about certificates. So whatever certificate you have, I don't care. It's neither a plus nor a minus. But if you put a lot of value on that certification, then I'm going to challenge you on that. So I'm going to ask you why. I want to know why you put that much value in it. But certifications is a shortcut for people who are not testers and usually work in HR departments to make their hiring simpler and then also cover their asses because they can still point to, oh, they had a certificate, so it's not my mistake. So I think certifications in testing are useless. They have no value to me. Okay, thank you very much. So if you want to have one of these House of Test notebooks, for people who have asked a question, please feel free to get one. Thanks a lot. Enjoy the rest of the conference. Don't forget to speak to other testers and share your experiences. Thank you very much.
Друзья, аплодисменты.